Okay, so looking at number 3, this says that a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions, so again, we're finding the individual dimensions here, will produce a box with a maximum volume? So we have an open box. That means we do not have a top. So we have kind of to draw a picture. Maybe this is going on, it's not going to be perfect. There's our box, okay? It does have a square base. So if we're going to name our sides, these two sides are going to be the same, x and x. You'd use y and y, a and a. It doesn't matter the letter, but we just need to say that those are the same. We don't know what it is, so we use a letter. Which means that our height is the one that's different, so that's going to be y. And it says that, so there's our picture. For our primary, so our primary equation is always what we want to maximize or minimize. In this case, it's the volume. So to get the volume of any kind of shape, we're going to do length times width times height. And here, the length and the width are the same. So our volume is x times x, and our height is y. So we can also write that as x squared times y. So our secondary equation, this is what constricts, so what limits our possibilities, because we can't just think of all of the numbers on the earth. Because if it was the biggest one, we could just make it as big as possible. But what it says is the surface area is 108 square inches. So we need an equation for the surface area. Well, the surface area is the area of all the sides added up. In this box, we have one square bottom. So the area of that would be length times width, which would be x times x. We do not have a top, so we don't have two of those, but we do have a side. We have another side. We have 4 sides. So the area of a side is going to be, so we're going to add that on, x times y. And since we have 4 sides, we're going to multiply that by 4. by 4. So our surface area here is really x squared. We can rewrite it as x squared plus x times y times 4 can just be written as 4xy. Our surface area, they said, needs to be 108 inches, so we can set this equal to 108. Now we need to solve. I think that looking at our primary equation, it's going to be easiest to plug something in for y. So that means that I want to solve for y over here and get y equals so I can plug it in. So that means I'd have to subtract the x squared. Then with the y is still a 4x, so we're going to divide the 4x. So here these would cancel, and our second equation is y equals 108 minus x squared divided by 4x. Now, if we were going to take the derivative by hand, we'd probably want to simplify this, which would actually mean that we need to do 108 divided by 4x minus x squared divided by 4x, and we'd split this up and make it smaller. But since this section we are practicing with our calculator, we're just going to leave it like this, and we're going to plug that in. So to substitute it, our next step is substituting. So we're going to substitute that in. So v is x squared times y, and instead of y, we're going to put that equation, 108 minus x squared divided by 4x. That's our new volume equation. Well, the next thing that they wanted us to do, or that we need to do, is we need to maximize this. So if we weren't using a calculator, then what we would do is we'd take the derivative of this function, we'd find the critical numbers, set it equal to 0, do a number line, find the maximum. But we're actually going to do all that work with our calculator. So on the calculator, what you're going to press is F3, which is calc for calculus. And then for this one, you want to go to the number 7, because that one is the maximum, the function's maximum. That's what it says, Fmax. So when you type that in, what you see on your screen in your typing box is Fmax, and then it starts parentheses. Well, in those parentheses, we want to write our equations. Now be very careful when you're writing this equation. We have x squared, so we have x, and then we'll write it to the power. We'll use the caret button, squared. And we're multiplying that, so we're going to use parentheses because we want to keep this as a group. Also, we also want to keep this numerator as a group. Oh, come on. Here we go. Because both of those things are divided by the 4x. So that means we need to put a second set of parentheses for our numerator, 108 minus x squared, and close the numerator parentheses, and then divide that by 4x. There are two things down there, so we also need parentheses around our, our denominator. So 4x, parentheses. Now this will close what we're multiplying by. So every time you open a set of parentheses, so we have this one that says multiplying. We have this group that says numerator. We have this group that says denominator. Now we still have this parentheses that we have not closed, and we're actually not going to close it yet. Because remember, when typing into the calculator, we need to say which variable we're taking the derivative of, comma x. Because the calculator is only a computer, and it only tells you what you need it to do. It also doesn't know that x needs to be positive. We know that because we cannot have negative measurements, and we cannot have a 0 measurement. We have to have some kind of measurement. What dimensions? We're finding things. So when we measure stuff, it has to be positive. So we're going to do the vertical bar such that is what it means. X is greater than 0. From there, you can hit enter, and you will get x equals 6. From there, we can find our y because we have to get both dimensions. So to find y, we're going to plug it back into our equation up here, which is 108 minus x squared over 4x. So we have 108 minus 6 squared over 4 times 6. When you do that, you get 3. So our answer is we need to answer this question. So they're asking us about the dimensions. So the dimensions that maximize, because that's what they asked, volume are 6, did they give us measurements, square inches. So our box would be 6 inches by 6 inches by 3 inches. And that would be our answer to this problem. We have optimized this box and found the best setup for it.